Today we will talk about how to use external dependencies in Bazel. In Bazel, everything not from your main repository is called external dependencies. The external dependencies can be further categorized into predefined external dependencies, such as the source code from the GitHub or your local computer, and the external dependencies created by the repository rules. Before we talk more about the external dependency part, let's explain what is a repository rule. In short, repository is something that can create the Bazel repos on the fly as your external dependency. Let's look at a practical example. In this repository rule, I download the Bazel build file according to your host platform and makes the executable available as an external repository for the users to use. What you can see is that the implementation of the repository rule is very similar to the regular Bazel rule. It has an implementation callback function and a declaration. The context object is repository_ctx instead. Now it's time to take the real challenge, how to use another Bazel repository in your own Bazel project. And there is a very big history come out of this. The legacy way in Bazel to mark the repository root and external dependencies is in the WORKSPACE file. As you see, in many Bazel projects already exist today and perhaps start very early. So what actually goes wrong with the WORKSPACE file? Let's look at the dependency graph of three repos. Repo B produces a CPP binary. Repo A produces a library which will be used by Repo B, and both Repo B and A use a third-party external dependency. Now the problem is, when we want to build a executable from Repo B, what happens if the commit x1 is not equal to x2? It is a serious problem because the one definition rule is violated for the C++ programs. This is a very huge or serious mistake you cannot overlook in your project. You have to take good care of the external dependency management across many repos. And this is the reason why Bazel starts to replace the WORKSPACE with a modern mechanism module. The official definition of Bazel module is a Bazel project that itself is versioned, and the module being dependent are also versioned. You might want to ask, what is the magic here in the Bazel that enforces the one version rule in external dependency version management? The answer is minimal version selection algorithm adopted by module mechanism. There are 4 operations defined by the minimal version selection algorithm, and here we only focus on the first one to construct a build list for the given target. So now I pick the example from the link to explain this. This is an external dependency graph. A1 directly depends on B1.2 and C1.2. The question is, which transitive dependencies versions, in this example of B, D, and E, will be chosen? The minimal version selection algorithm will do it in this way. First, it starts to list the direct dependencies of A, and then recursively list the dependencies of all the direct dependencies. Of course, every dependency is versioned here in the list. Then, if a module exists multiple times, keep only the newest version. Here we are actually using the maximum version number, but why we call it minimal version selection algorithm? The entire principle of this algorithm set is to do minimal changes to manage the versions. This principle is reflected in the other 3 operations of the minimal version selection algorithm. We have just now presented all the pre-knowledge. Now let's go back to the real topic, how to use external dependencies in the module file. To define an external module, you can use Bazel_dep method in your Bazel module file. By default, Bazel dep will fetch the external dependencies from Bazel Central Registry, and this is a package manager or package hub of the Bazel modules. Everything including the module itself and the dependencies of this module are versioned. If you want to use a predefined external dependency from online GitHub repos or the local repository, you can call git override method or the local path override method. There are also 2 ways to use a repo on the fly. The first one is to use a method useRepo rule, and the second one is to use module extension. The method useRepo rule is simple and very similar to load method in the build files. You can declare the external dependencies in the module file, and the repos will be created on the fly once it is invoked. The second way, which is more complex, is to use a module extension to create the repo on the fly. The module extension provides a way to control how the repo rules are invoked to create the repos. Like the rule and repository rule, you have to define the callback function and also the declaration in the .bazel file for the module extension. And in the module file, you will use the method use_extension to create an extension proxy in this module. The repos created by this module extension are not visible unless you explicitly call the method use_repo in the module file to expose them. The example you see now is to use a module extension to create a Bazel beautifier repo, and this is a very simple one. It hasn't shown the power magic of the module extension yet, so let's look at a more practical example. Use extension from the module rules Python to create the toolchains of the specific Python version. The Python versions are specified in python.toolchain method in the module file. The pi_binary rule for the specific Python versions are created in the repo Python on the fly, and those created Python rules are used in the build files. If we read deeper in the source code of rules Python, we can find that a dictionary called tag classes is part of the module extension declaration. The method python.toolchain in the module file is a key in this dictionary, and the value part of the key is an object type tag class which defines the keyword arguments for the method python.toolchain. The interesting part would be how are these methods, aka tag classes of the module extension got used by the module file, are consumed by module extension implementation. To explain the working principle of module extension in a more understandable way, let's go back to the beautifier example. I created beautifier module extension with a lot of printout for observing purpose. This module extension is more complex in a way that it allows you to create a bunch of copies of the same beautifier executable. It is an absolute overkill for the actual usage, but good for illustration purpose. On the right side, I also show the module file of format tools and repo_x, both of which are using the beautifier module extension and creating several beautifier repos. A further note is that repo_x directly use format tools as an external module. Now we can check how the printout in the module extension implementation actually look like. Switch directly to repo_x, and following these steps, you can see something printed out in the terminal like this. If you don't see any printout, just do a slight modification in the module extension.bazel file, such as add an extra space or new line to make the Bazel files get reanalyzed. Then run the terminal again, you will see the printout visible from the terminal. The highlight in the result is that the module extension implementation callback functions is only called once, even if it has been used by two different modules. So in our case, the repo_x is a root directory, and repo_x directly depends on the repo format tools. All the modules, including the root module and external modules that use this extension, will be listed in module ctx.modules. The keys defined in the tag classes are the methods that you will invoke in the module.bazel files, and you can invoke the same method multiple times or 0 time. In our case, the initialize method in both repo_x and the repo format tools has been invoked twice. Correspondingly, there are two initialize tags in the two modules respectively. The keyword arguments where you pass into the module.bazel file are remembered in the tag class, and you can read them as data member of the struct. Eventually, the module extension needs to invoke the repository rules to create the repos on the fly. Keep in mind that Bazel does not allow you to create repos of the same name multiple times. Since we have initialized beautifier x1 twice, in the implementation logic, we have to abandon the duplication. When repo_x is a root module, 3 beautifiers will be accessible: x1, x2, and f1. Please note that it is possible to access f1 even if it is created in the external module format tools. If we switch the root directory to format tools, the only beautifier repo that we can access is f1 because x1 has been commented out in the use repo method. This is the end of the day. Next time, I will talk about how to read Bazel API documentation from their website.